All right, we'll go ahead and get started. Good afternoon, everyone. Thank you for taking your lunch to sit in on this presentation about RPKI. I know this time is valuable for everyone, and I hope you get to enjoy some of your food while you listen and participate in this conversation about RPKI. For those of you that I haven't met, my name is Stanley Hahn. I'm the Associate Vice President of Engagement at CENIC. Engagement is a relatively new department, and the C2 tag is one of our first initiatives. And this webinar is the first for the C2 tag. So a lot of firsts today, I know. Um, with me, I have Chris Bruton, who is a network architect at CENIC, and he will be giving the presentation on RPKI. We also have a very special guest, Steve Wallace from Internet 2. Steve's done a lot of work on RPKI. He's put out a lot of papers on it, worked closely with Aaron, worked with a lot of other research and education networks. So thank you very much, Steve, for joining us today. We really appreciate it. So before we get started, Chris is signing on to the Zoom right now, and he has some slides to share. But I do want to take 1 minute. I promise it'll only be a minute. I want to do a quick marketing pitch about the C2 tag, which stands for the CENIC Community Technical Affinity Group. So I'd imagine that everyone here today is somehow connected to CENIC and uses the California Research and Education Network daily, I'd imagine. We feel that there's another network that's very underutilized, and that's the human network of all our members. There's a huge opportunity for our members to connect with one another, troubleshoot, brainstorm, and just get to know each other, help each other out. And that's our vision for the C2 tag. That's where the C2 tag comes in. We see it as a platform for our members to connect with one another. And today's a really good example of that. There was some conversations in the C2 tag Slack channel that we just created, and that resulted in this presentation today about RPKI. And that's essentially what the C2 tag steering committee and I envisioned for this. So that's it. If you want any more information about the C2 tag, please reach out to me. And with that, I'll hand this over to Chris.
Share. Okay. Maybe. Well, a few of us are in a room together here, so we're coordinating on the muting aspects and audio aspects. But sounds like or looks like people can hear me now. I'm going to turn my volume up. All right. So hi, I'm Christopher Bruton, network architect at CENIC. Many of you may have met with me or talked to me before at various meetings, but today I'll be talking about RPKI, routing security. This was based in part on some of the discussions that we had in the Slack channel for C2 tag. So I have a bit of a deep dive into some of that later on in this presentation. Some of these slides were reused from a presentation I gave at an APAN meeting a few years ago, which was funded in part by an NSF grant, the acknowledgement down here. So let's okay. So RPKI, what does it solve? There's probably varying degrees of technical understanding of RPKI in the audience. So I'll just go over super quick overview of what we're doing here. So this diagram, I borrowed it from APNIC. And this shows a situation where a bad actor, represented by this devil, may be advertising a
You're silent.
advertising your legitimate prefix out of a different ASN. So, suppose you here refers to an upstream provider. It's not a campus. Sorry for that confusing terminology, but say you are AS17821. You have this legitimate /48 that you're advertising, but someone else is advertising the same thing. Since they have a shorter AS path to whoever you are, whoever this provider is, then that route will win out because of the shorter AS path. So what route origin validation does is we have cryptographic assertions of who is allowed to advertise a certain prefix. So only the address space holder, the registrant, is able to generate an ROA, a route origin authorization, publishes it to a global RPKI repository, which validators hosted normally locally around the world will pull from and communicate with an individual network's routers using a RTR protocol. And this way, this router in the middle here will then be configured to check whether the origin of the prefix matches the authorized origin in the global repository. So in here, 65552 is not listed in their RPKI repository. Only 17821 is. So even though this AS path is shorter, this router will reject that route as invalid because 65552 has not been asserted by the address space owner to be allowed to advertise that prefix. So, okay, here's just quick overview. The repositories are hosted by the regional internet registries, typically. The top level, they can be delegated. You can technically host your own, but I think the vast majority of networks will use the hosted solutions from, say, ARIN, APNIC. And as I said, they contain cryptographically signed ROAs. The validators are typically hosted locally, so they pull from the repositories and cryptographically validate. So comparing public keys, and they'll serve a cache of validated ROAs. The routers will pull from that cache, and the big advantage of this, they don't have to perform the cryptography themselves. So this validator is some server, some computer that can do those cryptographic operations efficiently, whereas a router may have very low processing power, memory, whatever. So it just talks to the validator to So quick overview at CENIC. So we've implemented 2 validators. We have one in Sunnyvale, one in Tustin, and they're running on with minimal resources, and our systems team has deployed them with Ansible, so they can redeploy easily if needed. We've rolled out validator configurations across our backbone. So each router will connect to both Routinator instances for redundancy using the RTR protocol. I think it stands for router to router, very straightforward. Validation state now appears in the routing table. I have some screenshots, maybe they're too small, but we can see this list of routes, validation state valid. Currently, we're not rejecting invalid routes, and I'll talk about that on the next slide, but we do have import policies staged for easy implementation once we want to pull the trigger on that. So what's next? So these timelines are obviously very tentative. In my previous version, I had 2023 on this slide, but we haven't done it yet, but we do plan to implement validation on our ag routers, starting with our PNI and Exchange peers. So the Apples, the Dropboxes, Amazon, Google, and so on. That's almost a stage 1 pilot to make sure it works as expected before eventually we will also reject invalid routes from downstream associates. And that will only be implemented after substantial planning. This slide was made last year before the ARIN deadline for for bringing legacy space into an active RSA. We're pleased to see that many networks have done that and have signed RSAs, so they now have access to RPKI resources. I think that the meat of this presentation is going to be on some of the pitfalls and things to look out for when generating and signing ROAs for their prefixes. So I don't know if we can just go over this slide quickly. So best practice is to generate ROAs for the exact prefixes that we advertise, to avoid using the max length parameters. So I think this may be the first slide that shows an ROA. It's a combination of an AS number, a prefix, and a maximum length. So in this case, this ROA is considered as it covers this entire /16, but it's only considered valid for prefixes up to a length of 18. So this table here shows some quick examples of what might be originated in BGP and whether it would be valid based on this exact ROA. So the /16 with 65420, that's the exact prefix, it's valid. Here we have the same AS. This is a /17 that falls within that /16. It's also valid. 65421, that's the wrong AS, so it's invalid. Here's the tricky one. This is 65420, which is the right AS number, but this prefix length of /24 is larger than this max length. So that's considered invalid. And then suppose we have 654, I think that was supposed to be 65420, with a /8, it's not found because it's not covered by this /16. So it's neither valid nor invalid, it's undetermined. So next slide. These are some of our internal challenges. Our address space has been, not all of it is actually held by CENIC. We're using a lot of our address space is still held by CSU, Chancellor's Office, I think, and we're kind of actively working on bringing more of those into CENIC. The other issue is we often reallocate our address space to our associates. So one example here, we've allocated various /48s out of our /32 in IPv6. So we have to be careful if we create ROAs related to our /32 space that we don't inadvertently invalidate something from one of our associates. So that's the basic overview. Maybe pause for a minute for if anyone has questions so far, before I get into some examples. I see Steve unmuted, but.
Yeah, so the one comment I would make is one of the things we're finding is that people who have DDoS scrubbing services from various vendors, where they might dynamically announce typically a /24 for any part of their space to provide scrubbing services. That's a case where the max length, while not the perfect solution, seems to be the best solution.
Yeah.
And so that's one of the things that comes up when we look at this issue.
Sure. And I'll get into that now. I have some examples to kind of demonstrate that and some of the options. Okay. I can't see this. So okay. So in some ways it has similarities. The technical advantage here is that when you're using an IRR registry, then you have to have infrastructure in place to pull and update and maintain prefix lists, and implement filtering on your network devices. RPKI is basically automatic. It's the routers have their validator features purpose designed to pull from validators, which pull from the RPKI repositories. So in a technical sense, it's a much simpler solution if you're performing this validation. The other important feature is mainly relevant for RADB and other third-party IRRs. They're not considered authenticated sources. So it may be difficult, but it's possible for someone who doesn't own a prefix space to generate objects in RADB. I know they do some basic verification, but it's possible to exploit. Whereas using the RPKI repositories hosted by the regional internet authorities, you're essentially guaranteed that only the owner or the holder of the address space can generate these assertions, assuming their ARIN account isn't compromised, which is a big risk. Is a risk that can cause a lot more trouble than just RPKI.
One other question from George.
So I mentioned that briefly on one of my slides. I think we're currently very tentatively targeting next calendar year, sometime in 2025. I don't really have any more specific dates than that. I think what I do want to say is we will work to make sure there's no impact. I mean, we have to be very careful. We'll roll it out in stages, and we'll talk about we'll work on that plan in the coming year. Yeah.
So it seems.
Yeah.
Sorry, it seems like there's conversations happening that those of us on Zoom aren't hearing.
Oh, Stan, you're muted, aren't you?
Right, we can't hear Stan.
Yeah, okay. Okay, so did you hear that question that was read out? The what cost or resource?
No, did not hear.
All right, so it's in the chat. What cost or resources would be needed to implement from a K-12 HSN node site? So the implementation of validation is relatively simple. I mentioned if you're able to host a VM and you have some systems team who can manage software and OS updates, you're able to host a validator, and you really need two for redundancy. But I think the thing is, it's not necessarily necessary for all CENIC associates to perform this validation. If you only get the idea is that in the next few years, CENIC ourselves will prevent these invalid advertisements from propagating to our associates. So it's probably more important if you have other providers as well, where you also get full BGP tables. So if you've got CENIC and then some other commercial provider where you both bring in, you're basically multi-homed, then it would benefit you to implement your own validators. But if CENIC is your sole connection to the outside world, then it's really not needed at all in terms of implementing your own validators for your own equipment. I think the other side of this question was implementing ROA signing and publishing, and that's I think cost of resources is very minimal. As Steve has said, it's the easy button to routing security. But again, if you have these, if you're incorporating DDoS mitigation, then that can complicate things substantially. So there's no cost. If you've got an ARIN account, you've signed an RSA, you own your space or you hold your space, then there isn't really costs beyond that to publish these ROAs. There's engineer time for planning and doing it right.
So I would also add that the good news is that most of the tier 1 internet service providers do route origin validation. Internet 2 does route origin validation. It sounds like CENIC will do it in the future. It's already the case that most internet traffic traverses networks that do route origin validation. So if you create these records, most of your traffic will be protected regardless of whether you implement your own validation. So the really good news is if you just simply create the records, don't install any new infrastructure, that you'll receive protection for most of your traffic.
All right, I think I want to move on to these example slides because I've got quite a few of them, which shouldn't take too long to go through. But I wanted to present some examples here to show in practice what ROAs can actually accomplish in a network. So again, this you here is not you as a CENIC associate. This is really a intermediate provider, a tier 2 provider like CENIC, for example, or a tier 1 provider. But you are the one in this context. You are the person, the network who holds this address space. So scenario 1, so the unspoofed invalid origin. This is really with the most basic situation. I think this is the same one that I showed on an earlier slide. So 17821, except here I've reversed the ownership. So here 65552 is the legitimate holder of this prefix. They've published an ROA with unspecified max length. When it's unspecified, that means it's only valid for the exact prefix. So we have 65552 who is originating /32. We have 17821 who's also originating the same /32, but only the one from 65552 is accepted because they have an ROA published for this space. So next one is a spoofed origin, but a longer AS path. So here is this actually different? Okay, yeah. So here the origin is spoofed. So we have this bad actor who doesn't actually own this AS number, but they're pretending to be 65552. This has an ROA published for that origin ASN. Here, it's actually considered RPKI valid. So even though it's a bad actor, because they're using your AS number, then it's considered valid. But in this case, the legitimate source has a shorter AS path length. So it will be preferred by this tier 1 or tier 2 provider. And the reason this is important is because it can take it can be very challenging to originate a spoofed address, and it will often have a longer AS path length because it may be routed through multiple ASs to figure out who is actually vulnerable to allow them to spoof addresses. So here's where we start talking about more specific prefixes. So here we have a /32, which is legitimately originated by 65552. We have a /48 within that, which is maliciously originated by someone pretending to be your AS. So in this case, if you have no rows at all, then both of these are considered RPKI unknown. They're not found. Since a /48 is a longer prefix, it's more specific, it becomes the preferred route to that /48. So traffic that should be directed to you is being directed to this malicious actor for that specific /48 prefix. So here's the same situation, but now we have an ROA created. So this malicious person is still spoofing your AS, But now we have a ROA that said with unspecified max length, meaning the only advertisement allowed is this exact prefix. So this /48 gets marked as invalid because it's not part of this ROA. So here we have the valid /32, and it's preferred because here it's the only way to get to that /48. So here's where we start talking about DDoS mitigation. So here we have a legitimate origin, which is your DDoS mitigator service, who's using your AS number to originate the /48. In this case, so this is almost the same that the spoof, the bad guy was doing here, but here you actually want this to happen. So without any rows, they're both considered RPKI unknown. The /48 advertisement is preferred because it's a longer prefix, more specific prefix. Here, now we have a ROA created with, again, with max length unspecified. Now though, this /48 will be considered RPKI invalid, since this ROA is only valid for the /32. Here we see the /32 is valid, and it's the preferred path because the /48 is invalid. Here, you don't want it to be the preferred path. The preferred path should be to this DDoS mitigator, not directly to you. So here's a solution. So here's where we start playing with the max length parameter. So we have the same ROA for the /32, which means it covers 32 and anything longer than that, up to a max length of 48. So now we have the /48 originated by the DDoS mitigation service, and it's marked as valid. And now it's preferred as the more specific prefix, which is what we want, the green smile. All right, so this is good, but the impact, the consequence of this is that now a bad actor could do the same thing. So they can now illegitimately spoof your address. And now it's not just marked as unknown, now it's marked as valid. So this ISP is considering the bad guy to be validly originating your prefix. And since it's more specific, it's a /48, it is now preferred prefix. So the sad face. So this is the dilemma with DDoS mitigation, and I present some solutions here and discuss it a little more. So in an ideal world, one thing we could do is publish a ROA on demand. So the ROA will only exist when it's needed. So during a DDoS situation, the ROA is, so on this slide, there's no DDoS situation at all. We only have a ROA for the exact prefix, the /32. So this will prevent this kind of spoofing. It'll prevent, I'll stop flipping. You know what I mean? It prevents spoofing by a bad actor who's advertising a /48. In a DDoS mitigation activation, then you would publish a ROA for that specific prefix, that /48. So now your mitigator is allowed to advertise that /48. It becomes the preferred path for the /48. The rest of your network still remains the preferred path for everything else. So that's the ideal world. If everything were instantaneous and perfect, then that would really be maybe the best approach here. But it may not be a realistic solution. So it requires potentially complex automation workflows. Your DDoS mitigator service has to coordinate somehow with either you or directly with Aaron, API to generate ROAs and revoke them when the DDoS mitigation is deactivated. I have this question here. Do DDoS mitigation providers currently provide this functionality? I don't know, actually. So I was hoping someone might know that who's here. And then if you know, we can talk about it later. The other problem, which is more the technical issue, is it relies on ROAs to propagate to validators worldwide. So this isn't instantaneous. Our Routinator software updates, it pulls new data every 10 minutes, but maybe that is too slow for DDoS mitigation to take effect. Maybe other networks have longer update intervals, 20 minutes, 30 minutes, an hour. I mean, it really depends how you've configured your validators. So I think the question here is then, is this too slow or not? Is it fast enough to mitigate your DDoS attack within 30 minutes or an hour? I would love to do a kind of research project to figure out how long it actually takes to propagate worldwide. Maybe Steve has a comment on that.
Yeah, so folks have done research on the propagation of ROAs, and I don't recall all the details, but it can take a while. I think 10 to 20 minutes is probably not that far off the mark, but there can be delays. And because the system inherently assumes that the sources of the ROAs are not always reliable, it could take longer. I'm unaware of any DDoS providers that would do this. For them to be able to do it, they'd have to be a routing POC for the holder of the IP addresses. That would be the only way they could create the ROAs in question. So that would be be part of the onboarding process for a DDoS customer, that they would designate the DDoS provider as a routing security POC within Aaron to create the ROAS. So I think there are challenges to that approach, and it is an interesting balance. What I've heard people say in the past is, one way to mitigate the downsides of using max length is to use something like BGP Alerter to monitor when more specifics are announced in the global internet. So in other words, if you have a DDoS scrubbing service, then one way to provide the best protection using RPKI ROAs is to have max length so the DDoS scrubbing service can be responsive to a DDoS attack, but at the same time being using a tool like BGP Alerter or some other tool so that when a more specific is being announced within the internet.
Yeah, I think that, okay, so you wouldn't be announcing all your prefixes all the time, but if you detect one being illegitimately originated, then you also originate it, so there's a competing route in the BGP tables. So I think I made this slide pretty quickly, so I probably should have mentioned that scenario in this third bullet. But these are some of the compromises we could make. So one is to just not publish ROAs at all, which is not what people actually want to do, but it does have the advantage of there's no chance of your forged origin announcements actually being marked as valid, and will only rely on existing prefix ASPath filtering methods. I think where I was trying to go with that is some networks may have import policies that prefer the RPKI status over the IRR status. So the assumption is that if there's a valid ROA for some prefix, then you don't have to care about what's in the IRR databases, but not publishing ROAs can cause it to fall back to the other method. So I think your big risk is you'll be perceived as lagging in security and other disadvantages of not publishing ROAs. So I think the solution we've probably settled on more realistically is to publish ROA ranges using the max length parameter. It'll still protect against misorigination, which was one of, I think, my very first example where some other ASN tries to originate your prefixes using their own AS number. You know, we still protect against that, but you remain vulnerable to forged origin advertisements. So one preemptive approach is to publish ROAs using max length parameter, and also advertise all the specific prefixes protected by DDoS mitigation. So Steve was mentioning you could do this on demand, which may be easier than actually publishing ROAs themselves on demand. Publish or originate your prefixes only when you detect someone else doing it maliciously. And but when DDoS mitigation is activated, you want to withdraw those specifics because you want your DDoS provider to be the preferred destination. So that does require some automation or quick actions by engineers. And the last bullet point is mainly for if you're doing all of this preemptively, this could dramatically clutter the global routing table, you know, if you're just advertising everything that you could possibly need in advance. So that may not be a good solution either. But I think all in all, I think I like Steve's suggestion of using monitoring tools. And then this is my last slide. So really in how to make these decisions, it comes down to what's your risk tolerance and what's most important to your security posture. Suppose you were to implement the ideal solution of automatically publishing a ROA in a DDoS scenario, but maybe it takes longer to propagate worldwide, and you're vulnerable or you're impacted by the DDoS for longer than you would otherwise. What degree of automation do you have the resources to implement? And of course, if you're thinking about the solution to preemptively originate your specifics, how many actually need to be protected from DDoS attacks? You know, here, if you have a /16, there's 65,000 /24s. Is every single one of those in use? Is every single one of those intended to be reachable from outside? So do all of those need to be covered by your DDoS mitigation tool? You know, maybe if only a small subset of those need to be covered, then instead of using max length parameter, you can create specific ROAs for only those specific prefixes. Those are then still vulnerable to spoofed origin, but it's not the entire /16 that would be vulnerable to that. And I think one other question I thought of was, is the DDoS risk just to a specific host being targeted, or is there also concern about the upstream transit circuits being saturated? So depending on the extent of the attack, and maybe it depends on whether you have a 1G or 10G or 100G uplink. So yeah, I put this in for kind of some food for thought, and that was my last slide. So I think we can open it up for questions.
There was a question earlier from Luis asking if have we seen many of these sorts of attacks, or perhaps human error that may cause ASN routing issues?
I mean, Steve maybe can think of more examples off the top of his head. I know there have been some big, you know, ones that get press, and I think sometimes they're human error, or sometimes they're legitimate attacks.
So I think most of the things are human error. That happens more often than the attacks, but the attacks do happen. So I'll give you an example of human error. At the beginning of the Ukraine war, Roscom, an ISP for Russia, created a route to essentially prevent their users from seeing Twitter. So they originated a route to Twitter that was an invalid origin ASN, and then they leaked that to the rest of the world. That's actually an error. I mean, they didn't intend to do that. They created a route to black hole Twitter for their users, and they neglected to prevent that from being propagated worldwide. And the fact that Twitter had a ROA prevented that from being propagated worldwide. So, you know, I think those are that, and just, you know, people mistakenly typing stuff is the more common mitigation against which ROAs protect, but also protects against intentional hijacking. But if you're sophisticated enough, there are things you can do. ROAs are not perfect. There are a set of things that are based on RPKI. So RPKI is sort of a general way to record cryptographically provable information. And so ROAs are the first thing you do with it. But there are additional features coming in the future. One is called ASPA, and another is BGP-SEC that rely on RPKI. So getting your feet wet, creating the ROAs, sets you up to take advantage of more sophisticated protections that will mitigate a greater range of attacks.
Hey, thanks, Steve. I don't see any more questions in the, oh, there's this one. Who would we contact if we'd like to participate? I maybe if you can clarify, or I can talk about both things. There's really, I think, not a lot to do at this time. I think where this is going to come into play for CENIC associates is when we eventually start to reject invalid prefixes, then you would, if you want to use RPKI, you'd have to generate publish ROAs, and that's something we can provide advice and support and assistance on when the time comes, or preemptively. I think if you have questions about generating ROAs, you can email our NOC address, and that'll get, usually it ends up on my list of tickets to respond to. So I think we're open to questions and providing advice for those implementations.
And Vern, I know, not just Vern, but everyone on here, this might be new to a lot of folks. So C2 tag might be a good way just to ask your general questions if you don't need to necessarily open a ticket or do any sort of work with it yet. If you just have general questions, Chris is on that Slack channel, Dennis, myself, we can, you know, certainly answer quick questions in that Slack channel if you have any.
See two more. So one question from George about a link. I don't recall offhand. Maybe that's the link. I think the other question, would CENIC offer its validators for associates to use? I'd say no. I think that's not, I mean, I haven't been asked that question before, but I think for the best security posture, a validator really needs to be internal to your network, because it's probably not going to be, it's not an encrypted, cryptographically verified connection between your routers and the validator. So as soon as that's passing, you know, certain network boundaries, then it's vulnerable to being manipulated. Whether that's realistic, I'm not sure. I think, you know, if this is something that associates are interested in, then maybe we can discuss it internally at CENIC and see if it's a possible service we could offer. But I think right now there's no plans to offer that. Steve posted a link about the route report.
Cool. And we're right at a minute over 12:46. So if there's any other questions, you can fire them away now. If not, you can email Chris directly. Steve is a resource from internet too. Steve, I'm not sure if you'd be if you would feel questions or if you'd be happy with speaking with anyone connected with CENIC or any of our members, but there you go. He put his email address there. And I think everyone should have my email address because I blasted this presentation out and tried to market it. So, reach out to any of us if you have any questions. But thanks again for your time. Thanks for joining. We're planning on doing more of these in the future. So if there's anything that anyone on here wants us to present on or talk about, please let us know. Thanks so much.
All right. Yeah, thanks for joining us.